prior to today, you would have said to me that the square root of negative 8 is no solution. Okay? That's what you would have said to me prior to today. Some of you anyway. But in reality, if we factor out the negative 1 and the 4 and the 2, you come up with the following. The square root of negative 1 is I. The square root of 4 is 2. So what remains under the radical is simply the 2. Okay? The square root of negative 1 is I. The square root of 4 is 2. And the 2 remains under the radical. Okay? Just a quick brief introduction. So let's go ahead and look at a couple of these examples. I'm having you go 1 through 41 odd, which is a lot of different things, so I'm going to go rather quickly, but most of it should be pretty simple once you kind of gather this. So example 1, if I asked you to tell me for A, the square root of negative 5, well, there's no square root for 5, but there is a square root for negative 1 now. The square root of negative 1 is I, which leaves you with I5. I radical 5 is your answer. Okay, because we factored it to negative 1 and 5. The square root of negative 1 is the letter I. In the same way, B, we've got a perfect square with a negative. Okay, so we can say that the square root of the negative 1 is I. The square root of 25 is 5. You always want to put that numeric item in front of the I. If you notice, I did that here and here. You kind of treat it like a variable, even though it's not. It's simply representing the square root of a negative 1. Letter C is very similar to this one that I did here, and I'll go ahead and do that one real quick. The square root of radical negative 50 is like taking a negative 1 times 25 times 2, which gives you square root of negative 1 is I, square root of 25 is 5, leaves my 2 under the radical. Any questions so far on how to manipulate the I? Okay. Working with the I, we're going to look at how to add and subtract these numbers. The little paragraph above talks about pure imaginary numbers. Pure imaginary numbers are numbers that were created or are used for math but really cannot be grasped or ascertained. The square root of negative 1. There is not a number that you can multiply by itself to give you a negative 1, because you know how negative times negative is positive, or positive times positive is positive, which is why they're called pure imaginary. They are merely representing something for the sake of working with the number. So example 2 is a bunch of pure imaginary numbers, but you can work with them. And I'm going to show you that. So A is, what if you have the square root of negative 16 minus the square root of negative 49? Okay? Square root of 16 is 4. Square root of negative 1 is I. Gives me 4I. Square root, minus. Square root of 49 is 7. Square root of negative 1 is I. Gives me 7I. Since these are both numbers preceding the same variable type, remember it's not a variable, but you can kind of treat it like one, the end result is a negative 3I. Which in the real world is what? Negative 3 times the square root of 1? Negative 1? It's not something you can simplify any further than that, okay? Square root of 16 is 4. Square root of negative 1 is I. Square root of 49 is 7. Square root of negative 1 is I. Subtract 4 by 7, you get a negative 3. And there's your answer. Letter B has us doing I radical 2 plus 3I radical 2. If you remember, when you have something preceding radicals, as long as the radical is the same type, you can simply combine those two things that precede it. The 3I and the 1I become 4I radical 2. Okay? 4I radical 2. And that's as far as you can go with that. Here's where it gets a little weird. The second part of this, I forgot to write that up there. I squared is negative 1. The square root of negative 1 is I, and if you square I, you get a negative 1. Sorry about that. Here's where it gets a little tricky. We're going to deal with this a little bit. Starting with example 3. I'll write it again. I squared is negative 1. I is the square root of negative 1. Okay. Starting with example 3, we're going to do some multiplying. Okay, so this is negative 1 times 4 underneath, and this is negative 1 times 25 underneath. Okay, so it's going to be 2I for the square root here, multiplied by 5I for the square root there. The end result follows the same rules of normal multiplication, I times I, and 5 times 2, which is 10I squared. But wait, there's more. I squared is equivalent to negative 1. So that means the answer is 10 times negative 1. Your final answer is going to be a negative 10. Okay? So when you're multiplying, if you end up with an I squared, that I squared represents a negative 1, which then carried over whatever the number is, changes everything a little bit. Okay? Second one. This was A. Let's do B, which is I 2 multiplied by I 3, which is going to give you, because you can't simplify the 2 and the 3 any further, I squared radical 6. I squared is a negative 1, so it's a negative square root of 6. Remember, if it's a negative 1, you don't have to write that 1. Just like if it's 1x, you don't have to write the 1. Okay, any questions on example 3? You guys okay so far? Maybe? Okay, great. Example 4 deals with radicals or imaginary numbers in the denominator. And just like with radicals, you cannot have an I in the denominator. Okay? No I in the denominator. They used to call it rationalizing the denominator when you had a radical. I don't know if they call it the same thing or what. They don't really have a name for it. But in this case, we're going to do a similar thing. If you are given 2 divided by 3i, somehow you have to get rid of that. The easiest way to do it is to multiply both pieces by 3i, thus renaming the fraction. So you end up with 6i over 9 times negative 1. Okay, 9 times negative 1. Oh no, they just did I times I. I suppose I could do it that way. I always just do both because I'm going to reduce it anyway. So let's assume I did it my way. It's 6i over negative 9, which becomes negative 2i over 3. What they did, and it's just I'm a creature of habit, they do it by I, which gives you 2i over 3i squared, which became 2i over negative 3. Same thing. Okay? So as long as you get rid of your I, either by multiplying by the exact same thing, you're still going to have to reduce in the end, or as they show it, all you have to do is multiply by the I, it's fine. Letter B, radical 2, radical negative 2. B, 6 over radical negative 2, and that's going to be I radical 2. If you factor it, it's going to be 6I radical 2. You have to rationalize your denominator by multiplying by both the I and the radical 2. That's why I always just multiply by both parts. I don't know, maybe that's why. So, in any case, multiplying by the I and the radical 2 in the top and the bottom. The numerator results in 6I, and the denominator, I times I is negative 1, radical 2 is 2, so you end up with a negative 2. Okay, everybody see that so far? The 2 and the 3 reduce, negative 3i 2 over 1. Okay? Because the 2 reduced with the 6. Okay? That's your answer. All right. How do you work with this when it is variables? And this is the last thing I'm going to show you. Wait, let me see. Actually, I guess I got 2 more things. Okay. All right. So example 5. Sorry, I thought I had almost done. Example 5. What if you're given things to add together that involve imaginary numbers once you solve it? So this is the first one, A. I've got radical negative 9x squared added to radical 1x squared. Okay, so this, the square root of 9 is 3. The square root of negative 1 is I. The square root of x squared is x. Ix or xi, I always put it in this order. Okay? It's just standard the way you're going to see it. The square root of 9 is 3. The square root of negative 1 is I. The square root of x squared is x. Same scenario over here. The square root of negative 1 is I. The square root of x squared is x. So you treat this like variables. 3xi added to 1xi is 4xi. Okay? That's your answer. And letter B. Radical negative 6y multiplied by radical negative 2y. Remember, you can multiply you can multiply radicals, doesn't matter at all. The easiest way to do it is going to be to factor out your negative. So I, 6y, multiplied by I, 2y. Okay, square root of 1 came out. Square root of 1 came out. I times I is I squared. 6 times 2 is 12. Y times y is y squared. The 12 can be factored into 4 and 3. The 3 stays under. The square root of 4 comes out. Y squared. Square root of y squared is y. That comes out. I squared is a negative 1. There's your answer. Okay? So this became 4 times 3 times y times y. The 4 came out, 3 stayed underneath. The y came out, square root. I squared is a negative 1, which is why you ended up with a negative. Okay? Last thing, and this, I think this looks a lot harder than it really is. You can use this to solve quadratics that up to this point, my friends, have had no solution. Isn't that great? 2x squared plus 19 equals 3. Let's subtract our 19 over. 2x squared equals negative 16. Divide by 2. X squared equals negative 8. And we could break this into a square root of negative 8, which is going to be 4 times 2, right, underneath there, times negative 1. Remember, that's 4 times 2 times negative 1. What comes out? A negative, or I'm sorry, square root is an I. 2, radical 2. Okay, I, 2, radical 2. But here's the cool thing. Plus or minus. Because the square root is either a positive or a negative. Because when you square it, you'll come up with that number because of the I. Okay? Remember, if you square this, it goes underneath and becomes a 4. If you square this, it goes underneath and becomes a negative 1. Whether it's positive 2 or negative 2. Squaring it brings it under as a 4. Squaring this brings it under as a negative 1. Okay? That, my friends, has to be your answer. Okay? That's one of the toughest things to grasp. I think you'll be fine, though.